The area of a circle uses its radius, and we can see this in this diagram here, but I can also use the GeoGebra applet to show us in real time. But really what we're doing is we're just taking a circle and we're going to cut it up into segments, and then we're going to rearrange the segments. So there's, of course, 1, 2, 3, 4, 5, 6, 7, 8. And then we have 8 segments here. I'm rearranging them. And as we cut the segments thinner and thinner, so we're going to cut it into halves, so that there's going to be 16 of them instead of just 8 of them, it's going to end up becoming closer and closer to a rectangle. And that's what we can see with this applet here in GeoGebra. So what we can do is we can straighten this circle just to kind of give an idea of what this measurement is. This is, of course, the circumference here that we are cutting out. And then we're going to dissect the circle into their parts. We're going to rearrange them. We're going to spread it out there, and then we're going to flip them over to be matched up. But of course, instead of just doing for 6 parts, we can cut it up into, smaller chunks, right? We can cut it into, for instance, 16. Spread it out and flip it over. You can see this is more representing a rectangle. And as we go even further, right, we can just cut it up into further. So let's do like 40 here. Cut it up and flip it over. You can see it's getting even more like a rectangle. And of course, we can actually just adjust this to where this is what we see before. It's not much like a rectangle. It's more closer to a parallelogram. But as we cut it up more and more and more, the slices get thinner and thinner until this approximately becomes a rectangle. And we're just assuming that we're going to do this infinitely many times, and it creates an exact rectangle that we're looking for. And what's important to note here is that we have c divided by 2, right? This is half the circumference because we had half of it was flipped over and moved onto itself. That's what created the rectangle here. So we have half the circumference. And that's what we see here. We have r is the height, right? Because this is going to be at a 90-degree angle here. And the length is the base is the circumference divided by 2. And as I've drawn here on this is the area of a rectangle is base times height, which is going to be c over 2 times r. But the circumference is just 2 pi r. So I'm just going to replace 2 pi r with the circumference. Of course, the 2's end up canceling each other. And so we get r times pi times r. And rearranging that slightly, we get pi r squared. That is the area of a circle. So that's all we need to do for this. We have a circle with a radius 2 1/3 meter. So we're going to have, right, circle radius is 2 1/3. And that means the area of this circle is going to be pi times squared. Okay, I can do that in a calculator. That's going to be approximately, I should do this approximately, we'll go 3 places, 104. The radius is in meters. Area is going to be a squared measurement. So it's going to be meters squared. Here we know the radius again. So the area of the circle is going to be pi times the radius squared. The radius is 200. So again, it's going to be approximate. I'm getting 125,664 approximated to the whole place. It's going to be miles squared for that circle. Now, if we know the diameter, right, we have to cut that in half because we have to use the radius here, not the diameter. Okay, for this one, we can see that we have 4 half circles. You can also think of this as 2 full circles, right? If I just rotate this around and I get this shape here, this is going to be a full circle. And the same thing is true for this one. That's going to be 2 times the area of one circle. The area of one circle, right? We know the radius. We have 2 times the area is going to be pi times the radius squared. The radius is 6. Then we want 2 times that area. This, of course, is going to be 2 times pi times 36. It'll be 76 pi, 72 pi, sorry. And a lot of times we like to leave it in this format because 72 pi is an exact representation, very similar to how we like to write fractions in their fractional notation because that's exact. But 72 pi, you can approximate this using a calculator, of course, using the pi symbol. Approximately 226 rounded to the whole place there. This is going to be in inches squared since the radius was in inches. Okay. For this one here, you can see that we have a half circle here, and then we have a triangle, and the triangle has a base of 3 inches, and this is a right angle here, so we know that this is going to be our height. So we have a base of 3 inches and a height of 14.92 inches. So this is the diameter of this circle, so we need to divide that by 2, and we're going to get a radius of 3 over 2. Or 1.5 would probably be a better one to use for that. Okay, so the area of this shape is going to be the area of the half circle. So we're going to have the area of the circle, which is pi r squared, and then we want half of that because it's not a full circle, right? It's not this full thing, just half of it. We're going to add that to the area of this triangle. The area of the triangle is 1/2 base, which is 3 inches, times the height of the circle, or the triangle, sorry, 14.92 inches. Okay. Order of operations, of course, works, or you can just type it all into a scientific calculator, and that'll get you what you need. 25.9143, if we run it to 4 places. And this is in inches squared, since our measurements were in inches. Okay, what is the area of the shaded region? The radius for each of the 2 semicircles, this large radius going to the outside circle here is 0.94 centimeters. And the smaller radius here going to the inner circle there is 0.78. So we want just this orange region here. And to do that, we can find the full region, which is going to be the area of this half circle of the big radius. And then we can subtract off the area of this portion here, which is the area of the half circle of the small radius. So all we need to do is find the area of this thing is going to be the area of the big circle. It's going to be pi times the big radius, which is 0.94. That's going to be squared. And again, this is a half circle, so we're going to take that by half. We're going to subtract that off of the area of the smaller circle, which is the smaller radius. And again, this is a half circle. It's not the full circle. That'd just be pi r squared. It's the half circle. So pi r squared divided by 2. All right, and I am getting in an area of 4323. And again, this is an area measurement, so it's going to be centimeters squared. Probably want to round to 2 places since the numbers we were given were round to 2 places, so 0.43, but that just gives a little bit more accuracy there.